Hello, welcome to another class with Physics Anchor. Today we'll be solving more questions from our JAMB past questions. So today we have 3 questions on the board and then we'll start right away. The first question, a 500 kilogram car which was initially at rest traveled with an acceleration of 5 meters per second square. Its kinetic energy after 4 seconds was dash. So in other words, in this question, they want us to find the kinetic energy after 4 seconds. So according to our culture, we start by listing the parameters given. So here we have initially at rest, meaning that what? U initial velocity is 0 with an acceleration of 5 meters per second square. Our A equals 5 meters per second square. And they want us to find the kinetic energy. We know that what? Our kinetic energy is calculated using half mv square, where m is the mass of the body and v is the velocity of the body. So let's look at it. Again, we have time. The time being given is t equals to 4 seconds. So the first thing to do here is for you to check all the parameters given if they are in their SI units. So we have acceleration 5 meters per second square. Meter per second square is the SI unit of acceleration. So we are good to go with that. And time is also in seconds. So we are good to go with that. So what we need to find now is that they gave us mass also. Don't forget, they gave us mass. Mass is 500 kilogram and it's also in kilogram, which is its SI unit. So we are good to go with that also. So to find our kinetic energy that we are being asked to find, we already have the mass. What is missing here is V. So it means that these parameters given to us must have been a clue for us to get our V. So we recall that if we have V, U, A, T, then we can use the first law of motion. So that's U plus AT. V equals to U plus AT. So we can use that. So we can now calculate our V using this. Our U will be 0, that we already know, plus 5 acceleration, and then we have 4 for time. So V equals to 20 meter per second. Now that we have our V, we can go ahead calculating our kinetic energy. So our kinetic energy will be Ke equals half mv square as written. So we have half times mass, which is 500, times v square, that's 20 square. So we can say half times 500 times 20 times 20. Well, we can say that 2 here, 2 will give me 10. So 500 times 10 times 20, that will be 500 times 10 will give me 5,000 times 20 will give me 0, 0, 0, 0, and then 10. So that will give me 100,000. So, and its kinetic energy, that should be in joules since we are actually working with energy. So that will be 100,000 joules. So it's possible that in your exam, because the figure here is actually big, so they may convert it to what? Kilojoules for you. That will be 100 kilojoules. That's like saying 100 times 1,000 joules. So that is the kinetic energy being asked for us to find in question number 1. So I hope you understand what we just did. So let's move to number 2. For us to solve number 2, let me free this space so that we can work on number 2. Right. An object of mass 50 kilogram is released from a height of 2 meters. So we know that what? Mass given is 50 kilogram and height is 2 meters. That's what? 2 meter. Okay, find the kinetic energy just before it strikes the ground. So we are being given the mass, okay, we are being given the height, okay, and then they ask us what? Kinetic energy. So of course, we know that what our kinetic energy equals half mv squared. But here, you will see that well, you are not being given velocity nor any clue to find your velocity. So you must remember our conservation law of energy that state that energy can neither be created nor destroyed, but can be transformed or can be changed from one form towards another. In other words, if we want to relate with this object that is being released from a particular height, so this is the diagrammatic expression. Let's say that object is a ball. They did not tell us what kind of object it is, but let's just say it's a ball. So if this object should fall at this place, this object has what? Potential energy. Okay, so the potential energy of the ball is what is actually changed to the kinetic energy when the ball starts moving. That is, no energy, no new energy is being formed other than just changing this potential energy so that what? This ball can actually what? Be in motion. So in other words, what it means that what? The kinetic energy they ask us to find is just the transformation from the what? Potential energy. So we can easily say in this place that the kinetic energy is equals to the potential energy, which is what? mgh. And of course, they did not give you acceleration due to gravity. Of course, you know that that is a constant. So you can actually say your g equals to 10 meter per second square. Except if you are writing a level examination, that's when you must use g as 9.81 meter per second square if you are not being given. But if you are writing any maybe WAEC or JAMB, you can always use your G as 10 meter per second square. So we have our G as 10 meter per second square. Our mass is in its SI unit, kilogram. Our height is 2 meter, but our G is 10, and then our height is what? 2. So let me write G here equals to 10 meter per second square. Okay, even though it was not given, we know that what? That is the value of our acceleration due to gravity. So you can then multiply this through, and then you have 1000. So that will be 1000 what? 1000 joules. So that is the value for the kinetic energy just before it strikes the ground that they ask us. So in this case, you must know that the potential energy is the one that is actually transformed to the what? Kinetic energy that the object use in dropping down. So I hope you understand that. All right, let's move to number 3. Question number 3. All right, you are doing fine if you are seriously moving with me. If a cage containing a truck of coal weighing 750 kilogram, so not to waste our time, let's just write it down. We can always go back to the question if we do not understand the question, but you know that what the parameters given, you may need them. So just try to actually cite them out like that. Is raised to a height of 90 meter. So I had something like height, so let me just jot it down. 90 meter in 1 minute. So this is 1 in 1 minute. In 1 minute, so that is time. Anything minute is what? Time. So let me write that. What is the total power expended? So they're asking me, the question mark is what? Power. Okay, so what does this mean? It means that what? There is a cage containing a truck of coal weighing this mass and is now raised to a height of 90 meter. Okay, so in 1 minute, what is the total power expended? So here now they gave me mass. I know that my power is what? Either energy expended over time, or you say work done. We have done something like this before, over time. Okay, so I can, and I know that the parameters given here already, I'm seeing something like m, I'm seeing something like h, and I'm seeing my g here. So that means that what? I can say mgh is my energy, and then that will be over what? Over time. All right. So let me state it here that what they gave us G, which is 10 meter per second square. Okay. So now I can easily bring this in by saying that let's check the parameters given. This one is in SI unit. This one is in SI unit. Oh, our time is in minutes. And you know that our time must always be in seconds. Second is the SI unit of our time. So we must convert this to seconds. That will be 1 times 60, and that will be 60 seconds. So like I can now bring that, my G that I cleaned earlier. So that is G. So I can put everything together that was power now equals to mass 750 times G, which is 10, times height, which is what? 90 over what? 60, which is my time. So let me try to cut this without using calculator. That is 2, that is 3, that is 2 here, 1. 2 in this place will give me 375. Okay, so I can now multiply 375 times okay, that's 375. 375 times 10 times 3. You can use your calculator, of course, not to waste your time if you have that. I'm just trying to actually uh, do the little I can without calculator. So that will give me 3750 times, okay, times 3, and that will give me 0, 5, 1, 2, 2, 9, 11. So this is what I'm going to have. And since I'm dealing with what? Power, that is going to be what? Watts. So you can also convert this to 11.250 kilowatts. Okay. So they can leave your answer like this in kilowatts, or they can leave it in what? In watts. So this is the summary of the 3 questions that we have today. So I hope you do have a good understanding of questions like this now, and you can try to lay your hands on questions that look like this in the past questions. We still have more questions like this, and I will still try to solve more even on in other topics. So try to intensify the way you study now. Share this video out to other students to benefit from. Subscribe, turn on the notification button, and stay loyal to your studies till you write your examination. Till then, that we meet again, remain blessed. Bye for now.